Hello everyone, I'm Nathan Yates with the Nortech Technical Service Department. Thanks for joining us for our second Tech Lunch and Learn of the season. We're going to be going over the top 5 tech calls on the furnace side that we get into tech service. Topics will include installation and pressure switches along with igniter troubleshooting. If you have any questions throughout the presentation, feel free to submit those at any point and we'll get to those at the end of the presentation. Let's take a look and see what we have. With the calls coming into tech service, we are able to categorize each call. The benefit of this is that if we start to see a trend through the calls coming in, we can gear training towards those types of troubleshooting calls. Whether we come out to your guys' distributorship or if you come to us at our main facility, we can gear training towards the type of calls that come into tech service and the questions that we do get into tech. So the top 5 tech calls that we're going to go over today include installation is by far the most common call that we get or that we categorize as installation, and we'll talk about that. The second one is your pressure switches and pressure switch troubleshooting. We'll talk about the limit circuit, the control board, Flue Components, which will also kind of go into installation a little bit, and the igniter. But installation, I didn't want to really categorize that as a troubleshooting call because that's mainly the installation of the furnace. So the other 5 topics that we'll go over are more on the troubleshooting side. Installation is kind of its own segment that we'll look in here, but from a percentage-wise, those are going to be the top percentages that we get into tech service. How we get to those percentages is the guys in tech, at the end of each call, we will categorize the call that we just took. And there's more categories, but those are the top 6, if you will, that come into tech service. So the first segment that we'll go over here is the installation portion. I've highlighted some things on this slide that we get most common questions on. Now, on the flue piping side of it, it's mainly when do we go to a 3-inch pipe from 2-inch, and this will determine based on your length of your flue run or if the BTU of the furnace requires 3-inch. So that's mainly what we get on the flue piping questions. The drain setup is pretty straightforward as far as using condensate pumps. Can we use condensate pumps? Yes, you can. Just make sure that the pipe isn't in the well of the condensate pump where you'd be double trapped. Also, too, with the drain setup, you just want to make sure that you prime any trap upon installation, or if you are servicing the equipment and you clean out the drains, just make sure that we reprime those because you probably will trip a condensate pressure switch if you don't. On the burner orifice side, this would apply to guys that will be going over to LP, along with the techs that are in high altitude areas. So if you look at the install instructions, we will give altitude changes and if you have to switch to a new burner orifice. So those are the type of questions that we get on the burner orifice side. On the LP conversion, again, you will be switching to newer orifices on the burner manifold, and along with the gas valve will have to be converted. Now, depending on if you are on the residential side, you'll be changing out springs on the gas valve. If you're on the manufactured housing side, if it's on the single stage stuff, you'll be just flipping the cap over on the gas valve and it'll be red in color and stamped LP on that little cap. Setting gas pressure, again, is a top priority, especially when you're working with LP, because you don't want to set the furnace up because that's going to be a really bad day if that happens. Just keep in mind on high fire for LP, you need 10 inches of water column on high fire, which would also apply to single stage furnaces. And then the last thing here is the blower setup. So on the blower setup, what I'll say on that is that we don't preset anything from the factory on the furnace side. So especially on the 2-stage equipment regarding dip switches, stuff like that, all the dip switches are going to be in the off position. So if you were to actually look at the blower chart, you're only going to be pushing about 400, maybe 500 CFM, depending on your duct static pressure. This is a very common call that we get into tech is techs will either, they'll start up a new furnace and they'll call us and say the blower's hardly pushing any air. The first question we ask is, what are dip switches set to? Generally, they're all in the off position, which is the lowest possible blower setting. And the main reason why we don't preset anything is because we don't know the application of the furnace that it's going in. On the variable speed side, you're able to pick a CFM, and the blower motor will achieve that. It'll ramp up or ramp down based on your duct static pressure. If you're on the fixed speed side, like our FG motors, you will have to take a duct static pressure and then look at the blower chart to see where your CFM falls. So those are two main differences on the variable and the fixed speed ECM motor side. On the PSC side, you can find this information in the tech specs of the furnace. And again, you're basing that on a duct static pressure. So that is an important piece of information that you need to have to confirm your CFM output on the furnace. So again, those are the top things that we get questions on the installation portion of the furnaces. The next thing that we'll take a look at here is pressure switch troubleshooting. So by far the most common troubleshooting call we get into tech in the winter time is going to be pressure switch calls. Now, this could be open pressure switch calls, closed pressure switch calls. Most of the time they're open pressure switch calls because all of our pressure switches are normally open. Again, meaning that when the inducer kicks on, the pressure switch has to pull in in order for the furnace to light. So just keep in mind, all of our pressure switches on all of our furnaces are normally open and they have to pull in. If we get a call on a pressure switch close fault, normally it's the tech that is prematurely jumping the switch out, which will throw that fault code on the board. So from a troubleshooting standpoint, if you want to jump out a pressure switch, just wait 1 second, let the inducer kick on, then jump the switch, and you'll be good to go as far as jumping out your pressure switch. The number that is on the pressure switch, and we'll look at here in a second, is the number upon pressure fall. That's not the number that it takes the vacuum reading in order to close the switch. Again, it's the pressure fall number that is on the switch. So generally speaking, just add 20% to that number and you'll be good to go. So if you're pulling 20% more than what the switch is rated for throughout the cycle of a heating cycle, you'll be just fine on that. But just remember, all the pressure switches are normally open. Now, what we have here is just a picture of a standard pressure switch. What I've highlighted here is the bold number is the opening pressure. That's what you guys are probably most familiar with on the actual pressure switch. What I've also highlighted on this picture as well is the close pressure. It's the text is a little bit smaller. It's not bolded. That's the vac reading that it takes in order to close that pressure switch. So for our example, it works out to an even 20% in order to close this particular pressure switch. But that is a general rule of thumb that you can use in the field when troubleshooting. Also too, the pressure switches are going to be wired into our board at our 9-pin plug for our single stage furnaces. And then if we have a 2-stage furnace, we'll be working with our 12-pin plug connector. On the single stage side, you will just have orange wires to designate your pressure switch circuit. On the 2-stage, you will have basically 2 sets of wires. Your orange will be your low fire, and then your purple or violet wires will be your high fire switches. On the 2-stage side, you will have a total of 4 pressure switches, 2 on your condensate and 2 on your vent side, but they will be labeled with those color wires as far as determining what is your high and what is your low. But again, those wires will go back to your main plug, whether that's your 12-pin plug on your 2-stage equipment or your 9-pin plug on your single-stage equipment. The second most call that we get into tech is going to be in regards to limits. Now, this can apply to anything from it being temperature related, along with maybe having a high ohm value on a limit switch where you could be getting a false limit code, along with the limit circuit potentially being grounded to the cabinet. So if that's the case, most of the time it will not actually pop your 3-amp fuse. you'll end up getting a false limit code on the board if your limit circuit is grounded. But at 11%, this is another main topic that we get tons of calls on in the tech service in regards to limits. So there's 4 types of limit switches in a furnace. You'll have your vent limit, which will really only apply to the high efficiency side. So anything that's 80% will not have a vent limit, but your vent limit will be located on the inducer. All furnaces will have a rollout switch. They'll have your main air heat exchanger switch, and then every furnace as well will have blower limits. You will have a blower limit on either side of the blower housing. So just keep that in mind when troubleshooting. So you'll have 5 limits in a high efficiency furnace, and you'll have 4 limits in a 80% furnace. So the vent limit basically will protect your flue piping, making sure that doesn't get too hot. Your rollout will protect the area in regards to the burner manifold if we potentially have a cracked heat exchanger. Also, if we have soot in the heat exchanger from not converting a furnace over, that will apply to your rollout limit. What I would just remind you guys is that the rollout and the vent limit are manual reset. So if those were to trip, you have to hit the button on the limit in order to reset that limit switch. The heat exchanger limit is essentially your main air limit. If that is going off on you, the first question we ask is, what is your temperature rise? So if you're roughly around 50 degrees on your temperature rise, you're fine. If you're pushing 60 degrees or more, we may have an airflow problem. Also, too, what we'll ask is, what is your return air temperature? Because a lot of times guys will give us an adequate temperature rise number, say like 45 to 50 degrees, but the return air vents will be either high in the ceiling or on the upper portion of the wall, which obviously hot air rises, and that'll give you a higher return temp, which could be a potential issue if your main air limit is tripping. And then your blower limits are there to protect your blower assembly. They're also there to protect the furnace when it's in a horizontal left or horizontal right position to protect the blower assembly. But the main air heat exchanger and the blower limits are going to be an automatic reset. So those snap discs, they should close once the furnace will cool down to a certain temperature. And then if you still have a call for heat, the furnace should then go back through a heat call on that. What we have here is a wiring diagram of a single stage furnace. This will apply to the high efficiency 90 plus stuff, your 92 and 95% single stage furnace, along with the 80% standard furnace. So you'll see you have 2 blue wires coming out of the 9-pin plug, and this will go through the entire limit circuit. And then it snakes down to your blower compartment where you'll have 2 blower limits, and then comes back to the 9-pin plug. So again, the limit circuit in the furnaces is going to be your blue wire circuit. So the next wiring diagram that we have here is the 2-stage equipment. The limit circuit on the furnace is kind of split up in between the blower board and your main board. Now, a question that we get on this is, what's the easiest way to jump out the limit circuit for testing? Maybe if we're having an intermittent issue that we kind of need to track down, or if we have an issue with maybe a high ohm value or a grounded limit circuit. The easiest way to jump out this limit circuit for testing is that if you follow the blue wire out of your 12-pin plug to the first limit it comes to, all you have to do is unplug it from that limit and then take that blue wire back to the R terminal. That will effectively eliminate the limit circuit in the 2-stage equipment. And again, we only recommend this for testing where we're trying to nail down a potential false code situation. The next topic that we have here is in regards to furnace boards. So normally how it goes into tech on this kind of call is guys will call in, they'll give us a scenario and they'll say we've replaced the circuit board and we're still getting the same fault code or the same situation and it hasn't been changed. This is probably, along with the limit and pressure switch circuit, guys will just replace parts and try not to track down either a voltage drop potentially to your gas valve, and they automatically think it's a board. Most of the time, it's not a board issue in regards to a troubleshooting call. That's probably the last thing I would tell a guy to replace is the actual circuit board, because we're going to be going through the limits and pressure switch circuit depending on what the call is into tech. Just keep in mind that board is the heart of the furnace. So on your 9-pin or your 12-pin plug from a low voltage standpoint, that's where all your safeties and pressure switches will plug into. You'll also have a 6-pin plug for your inducer and your igniter portion of that. The biggest thing that we tell guys is to try to know the sequence of the furnace, because that is very important in regards to troubleshooting. If you know the sequence, the startup of a G7 furnace, that will greatly help you in troubleshooting. So what should happen is when you have a call for W, the first thing that's going to happen is that the inducer is going to kick on. Once it proves pressure switches and that your limit switches are closed, the igniter is going to start to fire up. Once that happens and the igniter warm up, you'll then have voltage to your gas valve. And then once the gas valve releases the gas, the furnace then should light. So as long as you know that in the sequence of operation, depending on how the call goes for us or how the troubleshooting call goes for you guys in the field, that will help you out. So with that, the board will monitor all the safeties in the furnace, and we do have a green and a red LED on the board for troubleshooting. There will be a fault table on the wiring diagram for the furnace. So depending on the fault code that you're getting, you can look at that and see what your fault code is. But there's a green and a red light on there for troubleshooting purposes. They should be solid on, which would be a normal operation, but if you're getting a pressure switch or a limit fault, you'll get that on the green and red light LED. Also too, on the board, we do have a yellow LED, which is there for your flame sense. So under a normal circumstance, that should be a solid yellow. If you're in a poorly lit room, that light may appear to flicker a little bit, which is fine. If it's actually flashing on you, meaning it turns off and then back on, off and back on, that would indicate to you that you have a low flame signal, which generally will be under 1 microamp DC. So if you have that scenario, it's probably just a dirty flame sensor, and we just need to clean that up with either some steel wool or Scotch-Brite works good too. Just don't use sandpaper. That's one thing we tell guys not to do. Again, your yellow and the red and green LED should be a solid on the whole time of the furnace operation. With our boards, in regards to flame sense, they are polarity sensitive, meaning that when you do hook this up on a new installation, you need to have your L1, your 120 volts going to L1 on the board, and neutral needs to go to neutral. I know that seems very simple when I explain it, but we do get lots of calls on polarity questions. If you come up on a troubleshooting call where the furnace has been installed for a while, where it's not a new install and you do get a polarity fault, that is generally a new board scenario. The boards are polarity sensitive, and that's mainly due to how the furnace will sense flame. So if they're swaps, you'll get a polarity fault on the board, which is a green and a red flash at the same time in sync with each other. And just take a look at your line voltage coming in. The furnace needs to have a proper ground, meaning that if you end up using a copper pipe that's, say, adjacent to the furnace, the copper pipe has to be copper all the way to the street. If it transitions to PEX or galvanized before it goes out to the street, that to us is not a sufficient ground. When checking the grounding of the furnace, you want to measure your ground wire and your neutral wire, and you should read 0 under a normal circumstance. You're allowed up to half a volt. So generally when I ask that question is what is your neutral to ground voltage? Most of the time it's 0.00 something, which is totally fine. You're just, again, allowed up to half a volt between your neutral and ground on that. And then also too, just a quick reminder is that the blower speeds are not factory set. So what I have here is a variable speed board. You see the red box there on the variable speed board, that's where your dip switches are set. Again, that can be found in the install instructions. And then I have a single stage board there where you have selector switches to then set your blower speeds for a PSC motor setup. The dip switches and those blower speeds will have to be set in the field, again, based on your duct static pressure. But again, all that stuff can be found in the install instructions, which will come with the furnace. The next thing that we'll take a look at here is flue components. Now, we get questions on this from, does this furnace require 3-inch pipe? When should I go to 3-inch pipe? We also get questions on, with this furnace BTU, will I be okay on 2-inch pipe for the amount of length that I have? Again, all that can be found in either the tech spec of the furnace, which is available on our literature website, or in the install instructions as well. What I'll remind you is that the flue pipe, especially, it doesn't really matter for the intake, but the flue pipe has to be pitched back toward the furnace. This will ensure that any rainwater that you would have from outside, or more importantly, the condensation that will be generated with the high efficiency furnace, you want to make sure all that drains back to the furnace, because if the flue pipe is not sloped back, you'll end up stacking water or condensation in the flue pipe, and you'll end up eventually tripping a pressure switch on the furnace. So what we have in the install instructions is a 1/4 inch per foot from a slope standpoint back to the furnace. Also too, we get questions on what is approved piping material. So we have 8 different approved piping materials for our high efficiency furnaces. The most common piping material that is used is either scheduled 40 PVC. We also have the foam core on the PVC is approved as well. That's probably the most common piping materials that are used in the field. But there's a total of 8, and those can be found in the install instructions of the G7 furnace. Also too, in regards to when do you go to 3-inch, you want to look at the vent table, and we'll look at that here in a second. But you want to look at the vent table to determine if your furnace is only approved for 3-inch, because we have a lot of calls that come into tech with guys that are using 2-inch PVC pipe on either a 108 BTU furnace or a 120,000 BTU furnace. You cannot use 2-inch PVC pipe on those applications, but we'll look at that in a second. So just look at the vent table. You want to kind of map out your piping, your piping run, see what roughly you'll be at from an overall linear feet, and then what your fittings will look like from a 90s and 45 fittings to get your PVC outside. Also too, our furnaces can be direct vented, or you can have a single pipe installation. Either way, depending on what you have from an install perspective, it may be easier just to run one pipe. We always advise from tech service that you run a 2-pipe installation if you can, because you'll be bringing in fresh air into that furnace, and that will just help the furnace burn a little cleaner. The only thing that we'll also say is to make sure that if you have a 1-pipe install, make sure the room that the furnace is in can sustain that furnace for proper runtime. So you just want to make sure there's enough air or fresh air that would be coming into that room for the furnace to properly fire and run in that application. What I have here are 2 pictures directly from our install instructions. On the left-hand side is if you were to bring your piping outside on a horizontal application, so that's coming out the side of a home or a building. And then the one on the right is if you're going through the roof. Really what I'll say here is that the minimum distance you can have between your intake and a exhaust pipe is 8 inches, and then the maximum is 36. So that's your range on where the PVC pipe can be. What I'll also kind of say to this as well is you want to make sure that the piping goes out the same side of the building and within those dimensions, because what you don't want to do is have the intake pipe be on one side of the building and your flue pipe be on the other side of the building. I personally have had that call a few times through troubleshooting where I've had some really weird pressure switch calls, and that's when guys call us. It's related to pressure switch troubleshooting. But you want to make sure that the intake and the exhaust is in the same atmospheric zone, or you will have pressure switch problems. And that's your range, 8 to 36 inches on your allowable length for your intake and your flue pipe. So this table here is directly off of the tech spec in a single stage furnace. What I have here is the vent table, and mainly what I want to point out is what your 2-inch allowable length is along with your 3-inch. So you can see just by looking at this table, when you go to a 3-inch pipe, on most applications except the smaller BTU, is that you'll have 90 feet to play with. So that by far will get most applications out of the way from a piping install. You'll also have a lot more flexibility in your fittings. You'll be able to use more 90s if you have to work around some things in the home. If you go to a 3-inch pipe, there's nothing wrong with 2-inch pipe. What I just personally will suggest is that anything over 80,000 BTU, whether that's single stage or 2-stage, 80,000 or more, just go to a 3-inch pipe. This will cut down on nuisance pressure switch calls. Like I said, I'm not saying that 2-inch pipe, is not approved or adequate for a proper installation, but sometimes through troubleshooting, when guys are using 5 or 6 90s in order to get piping outside, that stuff adds up pretty quickly on a vent table chart. So the numbers that you will have here in the single stage and then also in the 2-stage table, that will include one long radius elbow, and then any elbow after that is going to be 5 feet. So like I said, if you've got like four or 5 90s in a vent run, that's potentially 20 to 25 feet that you then have to add onto your linear length. Also, too, believe it or not, we do get the question on is what does NA mean? It's non-applicable, meaning that you cannot use 2-inch pipe on a 120,000 BTU furnace. That's what you would see on this table here for a 2-stage piece of equipment, and then also on the single stage on the 108 series BTU furnace, you cannot use 2-inch. It's got to be 3-inch. And this again goes with when do we go to 3-inch pipe? We always advise to use long sweep fittings. Don't use plumber 90s or what I would call a regular 90. You always want to use long sweep because that will cut down on the restriction. And if you end up using regular 90s or plumber's 90s, I would add a few more feet onto that 5 feet per 90. So plan out your piping run. When you go to 3-inch pipe on a furnace, let's say you have 120,000 BTU 2-stage furnace and it requires 3-inch pipe. So on all of our furnaces, the PVC coming out of the inducer is going to be 2-inch pipe. You then have to transfer to 3-inch. So on a typical installation, what you'll have is the pipe coming out either the left or the right side on a 2-stage high efficiency furnace. The first fitting that you'll hit is the T, and then once you go vertical from the T, you'll want to hit 3-inch. So the only thing that we really tell guys from the tech department is go to 3-inch as quick as you can on that vertical run. So, sometimes that'll be different depending on the installation and what you're having to work with. Also, kind of as a side note, you never want to transition to 3-inch on a horizontal run because that won't allow the water and condensation to drain back into your drain system of the furnace, and you'll end up stacking water. So on that 2-inch to 3-inch fitting, just make sure that's on a vertical run and you'll be just fine. The next one that we'll talk about here is the igniter. So coming in at 5th place is the igniter from a troubleshooting standpoint. This is going to be very straightforward as far as troubleshooting in general. The igniter is going to be a 115 volt part that comes from your control board. And again, this is when the process of startup and the startup sequence will greatly help you if you know that. So if you are going through a startup sequence and you don't see the igniter kicking on, from a troubleshooting standpoint, what you want to do is make sure you're actually getting line voltage to the igniter, because if you're not, that may be a board issue. If you are getting line voltage to the igniter, then we may have an igniter problem. But the warm-up on the igniter initially is going to be a 30-second warm-up. And then once the flame is proven, then the igniter will de-energize on the furnace startup sequence. Now, the igniter will have 2 black wires going to it from the main control board. And again, that's going to be carrying 115, 120 volt going to the igniter. That will de-energize once the furnace is up and running. Also, too, you just want to make sure that the igniter is at least getting 90 volts. So that's what they're tested down to, is 90 volts. So if you're getting less than 90 volts, then we've got a line voltage problem, and we may need to address something in the electrical panel. From an igniter standpoint, just make sure you're getting line voltage to it when it's required, and if you're not, you may either have an igniter problem or a potential board issue. What I have here is just off of a single stage furnace wiring diagram. You have a 6-pin Molex plug, and what I have highlighted here, you'll have 2 black wires that go directly to the igniter. Now, between the Molex plug and the igniter, there is a 2-pin connector or Molex plug there for the actual igniter. So if you are having an igniter issue where it's not warming up and we need to test voltage, just unplug that 2-pin Molex plug, put your meter leads on there, and see if you're actually getting line voltage from the board. And that will direct you in a direction if you have an igniter or a board issue. But there is a 2-pin Molex plug connection there, just as a reminder. Also, too, what I'll talk about is on this slide, we have the Smart Light feature. So the guys that are not familiar with Smart Light, basically what it is that it reduces the igniter warm-up time by 3 seconds on every successful ignition. So the initial startup sequence is going to be a 30-second warm-up time, and then every successful ignition, it will then decrease by 3 seconds, and it will go all the way down to a 9-second warm-up time. That is a feature that we have on our furnaces. Now, what I will say, kind of as a side note, the guys that may be out in California with the new G8 furnace, the Smart Light feature is not on that furnace, and that's mainly due to the variable speed inducer motor that we had to put on that furnace in order to get the G8 furnace built. But the G7 furnace will have the Smart Light feature, and it's on the previous models of the G7 as well. So Smart Light feature is something I just wanted to make sure you guys are aware of in case you're finding the igniter only staying on 9 seconds or 12 seconds, for example. Now, if you end up killing power to the furnace and reapplying power, let's say if you had a 1-hour lockout code, that is going to reset the 30-second warm-up time. So you'll go back to 30 seconds, and then after each successful ignition, it will then work its way back down all the way to 9 seconds. So if you kill power, reapply it, you'll end up resetting the Smart Light feature. And that's the top 5 tech tips that we get into tech service coming in the fall and the winter time. I hope this presentation was helpful to you guys when it comes to troubleshooting in the field. What I also just want to make sure is that most of this information that we did cover is available to you in the install instructions and in the tech spec for the furnace. So, and all that again is available to you guys on the literature library. You should have an install instructions that comes with every furnace, but the tech tips again is available to you at the literature library on our website. Also, too, as a reminder, I want to make sure everybody is subscribed to our tech tips that we do have come out. So make sure that we subscribe to that, and we do cover a lot of things that would be in a lunch and learn in a possible tech tip that may come across your desk. So you can register with that on Enora. We also post them on our YouTube channel, but feel free to subscribe to that. Also, if you guys have any ideas that or topics that you do want to cover in a tech tip or in a possible lunch and learn, that is very helpful to us. So because this content is for you guys, so we want to make sure that we're putting out relative and meaningful content to you guys that is helping you on a day-to-day operation level. So there has been some questions that have been coming in throughout the presentation. Feel free to ask away, but we'll take a look at those now, and I'll answer those to the best of my ability. Again, if you have any other questions that may come up through answering the ones that have been submitted, just feel free to submit away, and we'll get to those. So the first question that we have here is, can the furnace prime itself after a shutdown? So basically on that, what you want to make sure is that all the traps that would leave the furnace are primed. On some of the smaller BTU furnaces, you can get away with not priming the trap. What'll end up happening is that through the first run cycle, water will collect in the collector box, and then as soon as the inducer shuts down, water will then drain into your main drain and will then automatically prime your trap. But on some of the bigger furnaces, you may not have the ability to close that condensate pressure switch. So again, on some of the smaller BTUs, you can get away with it, but I know on the bigger furnaces, you got to make sure that you prime the trap. Just to be safe and not have to worry about tripping out on a pressure switch. Just go ahead and prime the trap, and then you'll be good to go. So, to answer your direct question, yes, on some furnaces you can get away with not priming the trap, but you want to make sure that all the traps, whether you're a horizontal application or not, make sure all the traps are primed. So we don't trip a pressure switch on that. The next question is how do we jump pressure switches, or what's the best way to jump pressure switches for troubleshooting? So when it comes to pressure switch troubleshooting, we talked about it in the video, but essentially all that you have to do is wait for the inducer to kick on and then jump the switch out. So if you jump the switch out beforehand, you'll get a pressure switch closed fault. So on single stage furnaces, it's pretty easy. All you got to do is take the orange wires off. It'll roll through a coil for heat, let the inducer kick on, just wait like 1 second, then jump your orange wires, and that will effectively jump out your pressure switch for troubleshooting. And then maybe you can tee in a manometer to see what you're reading from a vacuum standpoint, and then go from there. But really, it applies to two-stage furnaces too. So on the two-stage side, you'll have purple wires for your high fire switches. Just let the inducer kick on, because all switches, regardless whether it's single stage or two-stage, are normally open switches on that. So just keep in mind, you'll get a pressure switch closed fault if you do it beforehand. Okay, so another question here is, when venting on the exhaust, do we need to have a coupling attached to the furnace? So on the single stage stuff, and this would really apply to the 92%, the G7 SC model, where you could have the flue pipe go through the top portion of the furnace. You don't need a coupling there. Also on the intake, and again, this would only apply to the SC model, is that there is a black trim piece, if you will, that the PVC pipe will set down on top of. There's also vents or louvers, if you will, in that fitting, and you just want to make sure the word front is facing you. It should be at the 6 o'clock position. So basically what it will do is divert air on the left side of the furnace, but you don't need an actual coupling to exit the furnace. There is going to be a factory installed Fernco that comes right off the inducer. It's got 2 yellow caps on it for your drain setup, if you need that, in order to get an extra drain outside the furnace. If you're horizontal right or horizontal left, that's what those caps are there for drain lines. But no, you don't need a coupling to attach into the furnace. When you exit the furnace, you'll either hit a 90 or a T, because you can do it both ways, and those are in the install instructions with diagrams. But most of the time, guys will come out, hit a T, and then you'll go vertical with your flue pipe. So you don't need a coupling. Okay, another question here that we have basically is in regards to checking flame signals. So I didn't talk about that in the video, but or in our presentation here, but Checking flame signal, all that you really have to do in regards to checking flame signal is, one, it's going to be a micro DC amp, so your meter has to have that unit of measurement in order to check flame signal. So that's one thing we need to make sure on. The second thing is on how you go about doing it is, what you'll do is remove the red wire off the flame sensor. You'll put 1 meter lead on the red wire, and then 1 meter lead back on the flame sensor, essentially putting your meter in series with the flame sensor. And then you'll have a call for heat, roll through a call for heat, and you'll have a micro DC amp reading on your meter. Now, a good reading should be anywhere from about 2 to 4 microamps as a reading. Higher number the better, but generally 2 to 4 is what you'll see. If you are closer to 1 microamp, that yellow LED, it may actually blink on you and not flicker, because it might have a slight flicker to it if you're in a poorly lit room. But a low flame signal, the yellow LED will flash. It'll turn off and then turn back on, and that would be an actual flash. So yeah, that would be the way to check flame signal, which would apply to all the furnaces that we have in checking flame, and the DC amp reading would also apply 2 to 4 on that. Good question, guys. If you have anything else that you want to discuss, feel free to submit that here, and we'll answer that stuff for you. Hopefully the presentation that we put together for you guys is meaningful to you. I want to make sure that when we put this material together for you from the tech department, that it is beneficial, that it does help you on a day-to-day basis when it comes to troubleshooting, and especially troubleshooting our furnaces. So hopefully that what we covered in the top 5 tech tips, along with or the top 5 tech calls, along with the install portion of it at the beginning, hopefully that was beneficial to you. You know, I'm not getting a whole lot of questions here other than those at the beginning, so hopefully that answered a lot of questions that we had. I'll give it another second here. You know, so if you guys have any questions, feel free to ask away here. So very good, guys. If you guys have any other questions in regards to this video, feel free to submit those. Also, you can also submit any types of questions or call into tech service. You can send questions in through the tech service email, which is hvac.techservice@nortech.com. Or you can call us into tech service as well. But yeah, so I'll kind of leave you with that. So again, hopefully this presentation was meaningful to you guys, and that it's going to help you in the field. Thanks for taking the time to look at this presentation that we put together for you. Stay safe out there. And if you guys have any other questions when it comes to troubleshooting, feel free to call the tech department. Thanks again for watching, and you guys have a great day.